going to try the factoring by grouping technique again on this problem, which came from section 2.4 notes, part B. This is number 3C. All right, so there are 4 terms here. Anytime that there are 4 terms, the only factoring strategy I have is grouping. So we're going to start by looking at a grouping that's going to group the first 2 terms and the last 2 terms. So I'm going to group like this to start. We're going to see how well this works. But I need to have groups of 2 to use the grouping method. Okay, 4 terms, just split them into 2 groups of 2. Now if I begin looking at this, I think it'll be a little faster if I just copy this line. Begin looking at this pairing. Now I can take that part back off. If I begin looking at the first 2 items here, I'm trying to find out what they have in common that I can factor out. So 10 and 12 can both be divided by 2. There might be a number in common. There also might be a variable in common, but in this case, they don't both have the same variable, so 2 is their only GCF. No number bigger than 2 goes into both of those, so I can just divide out 2. All right. Now, divide it out. So 10 divided by 2 is 5, and x squared stays, right, because you didn't take any x's out. That was supposed to be squared. There we go. And then negative 12 divided by 2 is negative 6, and the y stays. Okay, so we're just dividing this piece out. If I distributed it, I would get back to where I started, because factoring is the opposite of distributing. Now I look at the other 2 terms. Okay, so again, I'm looking at 15 and 8 right here to find out if there's a number, a numeric GCF. 15 and 8 don't have any common factors. 2 goes into 8, not into 15, and etc. There's no number that goes into both. So I can't take a number out, or I could take 1, but I can't take a non-1 number. They do both have an x, though, so I could divide out x. X is the GCF for those 2. Now, I always take out a negative if the leading term is negative. So I'm going to take out that negative with the x. So I divide that out, and with 15, negative 1 divided by negative 15 is positive 15. X took out. Then I'm going to have positive 8 divided by negative is going to be negative 8. X went out. Y would be left. Okay. So I have my 2 groups factored, but unfortunately, what is inside the parentheses here is not the same, which means that this is not the, see, I can cross this out real quick. This is not the way to factor this, okay? So I'm going to have to do something different. All right, so let me grab that original. We're going to try again. Again, we have to use grouping, but it can be any 2 terms. Oftentimes it doesn't matter what order they're in, but occasionally when there are both x's and y's, it might. So I'm going to try to rearrange these into a pairing that has more things in common, like 10 and 15 work well together. So let's put those together. So I'm going to regroup this so that I have the 10x squared and the 15x together, and then I have the negative 12y and the 8xy together. So we're going to regroup them like this. Okay. Now we're going to try just the same process again and see if we have any better luck. All right, so the first, oops, just trying to clear that out so I can factor. The first 2 terms now, 10x squared and 15x have a numeric GCF. 5 goes into both 10 and 15. And they also have a variable GCF. They will have at least one x. So the greatest common factor is going to be 5x for those 2 pieces. Divide it out. 10 divided by 5 is 2. We had x squared, but we took one x out, so there's one x left, right? We already had an x removed, so out of x squared, 1x left. Keep going. We're dividing this out. Dividing out your greatest common factor. Negative 15 divided by 5 is negative 3. There was an x, we removed it. There are no x left. So that is the first 2 terms now factored. Okay. Now we try again on the last 2 terms. I'm always going to take out a leading negative, so I'm going to keep that negative there. And I look for a number that goes into both 12 and 8. 12 and 8 can be divided by 2, but there's a bigger one. I want the greatest common factor, which is 4. I can divide both 12 and 8 by 4. They also both have a y, so I have both a number and a letter that can be taken out of both a numeric and a variable GCF, greatest common factor. Now we divide that out. Negative 12 divided by negative 4 is positive 3, and the y came out. Okay? Then I have a positive 8 divided by a negative 4 is a negative 2, and the y came out, but the x is still there. We got very, very close this time. Okay, the pink part's factored, the green part's factored, but they don't match. The insides don't match. So one more time, I didn't happen to get it right. Okay, I forgot to cross this off. There we go. Didn't work. Okay, but we were really close. So now I think we know what to do. If instead of negative 12y plus 8xy, you see how these two terms are the same but in the opposite order? If I just reorder this one, I'm going to cut it. If I just reorder this one and put it at the end, now when I factor this one, they should be the same. Parentheses. Okay, so let's do it. Oops, that plus should have still stayed there. Sorry. All right. One more time. Now I have a positive, leave the positive, GCF of 8 and 12. 4 goes into both of them, and they both have a y. Let's try this again. 8 divided by 4 is 2. Took out the y, the x is still left. Negative 12 divided by 4, negative 3. The y came out. Okay. We are finally at a point where we have the same factor here. Our binomial GCF, greatest common factor, is the same. Okay, so remember, I'm using a binomial factor. This is the same as factoring something, switching color real quick, factoring something that looked like 5x times a plus 4y times a. It's just that instead of that common factor being a monomial, it's a binomial. Again, if it was an a for a second, oops, I meant to copy. If it was an a for a second, you know that you could factor that a out, right? You could factor that a out of both of them, pull the a to the front, and you would have 5x plus 4y. We're doing the same thing here, except it's not a monomial GCF like a, it's a binomial GCF. So we're going to take it out to the front. I can make it a different color. And then in my parentheses, what's left is the two front pieces. This common factor got factored out, and its coefficients, 5x and 4y, remain. So this is our final answer. It has finally been factored. Now, if you were to check this, let me just take it out of its little box here. If you were to check this, you would maybe multiply it back together, and you could show that you did get 2x times 5x is 10x squared. Then you have 2x times 4y is plus 8xy, minus 3 times 5 is 15x, minus 3 times 4 is negative 12y. That is the same thing as the original, way back up here. It's just in a little different order, but it still has a positive 10x squared, a positive 8xy, and negative 15x, and a negative 12y.